Now that we know some trigonometry, let's use that trigonometry to solve some word problems. So let's get started with this. Is exciting. This is a navigation problem. So I have a ship and it needs to go from point A to point B. So let me draw that. So I'm going from point A, which is that point, to point B. Let me draw a nice big, well, not so big triangle. Big enough. There you go. Point A, because I need space to do my math. So let me, let's see. So this is point A. Point A, I will draw in mauve. Point A to point B. So this ship needs to go from point A to point B. And this problem tells us that the distance between point A and point B is 10 kilometers. 10 kilometers. So this guy sets sail, and because of whatever reason, he's a bad navigator, or the water is flowing faster, maybe upwards. Maybe the water is flowing in this direction. Let me draw that in blue to show which direction the water is. Say the current is flowing in that direction. And he ends up off track. He actually ends up after 5 kilometers. So he travels for 5 kilometers. Let me do that in blue-green. He travels for 5 kilometers. And after 5 kilometers, he realizes that he has gone off track. And somehow, I don't know, maybe using his astrolabe, I don't really know what one is, but that's what people use when they're on ships to figure out where they are, I think. He realizes that he is 15 degrees off course. So he is 15 degrees off course. So what that means is that he's between the path he took and the path he should have took is 15 degrees. At least that's my interpretation of it. So this is 15 degrees. And of course, he's traveled 5 kilometers in the wrong direction, 15 degrees in the wrong direction. So what he needs to know is, so this. Let me draw a little ship. So this is where the ship is now. That's my ship. So now this guy, this poor captain, needs to know, how far do I still have to go to get to point B? So he needs to know how far is. Let me pick a nice color. How far is this distance right here? How far is this distance? This may just involve some trigonometry. So how can we figure out this distance? Well, let's just break down what we know, and that's how I do trig problems. I just keep messing around with it until I get the right answer. So let's see if we can tackle this problem that way. So what can we figure out? We know that this is 5 kilometers. This side is 5 kilometers. We know that this is 10 kilometers. We know this angle. Well, one thing I know I can figure out is, well, let's just make some right angles so we can start using some trigonometry. So let me draw a right angle here. Right, just drop it straight down. So can I figure out what this side is right here? Let me draw that in a different color. It is brown color. Can I figure out what this side right here is? Well, this side is going to be what? This is, if we look at this angle, this is adjacent to the angle, and this is the hypotenuse. So if we know the hypotenuse, we know the angle, we want to figure out adjacent. What trig function should we use? Let me write down our SOHCAHTOA. SOHCAHTOA. So we know the hypotenuse. We want to figure out the adjacent. So what involves adjacent and hypotenuse? Ka, or cosine. So we know that the cosine of 15 degrees, so I'm going to write over this just not to waste space. Cosine of 15 degrees is equal to this brown side. So let's just call this, I don't know, I'm just going to call it x. Right? So this is equal to x over the hypotenuse, over 5. Right? And if we solve for x, we get x is equal to 5 cosine of 15 degrees. Oh, well, maybe we made progress, maybe we didn't. Let's keep trying. All right, now let's see if we can figure out this side of this triangle. Well, this is to this angle. This is the opposite, right? This is the opposite. And we know the hypotenuse, so what trig identity should we, or a trig function should we use? Well, if we know the opposite, if we want to figure out the opposite, and we know the hypotenuse and we know the angle, so what trig function deals with opposite? I was going to say hypotenuse, but anyway, what trig function deals with the opposite and the hypotenuse? Well, that's sine, right? So the sine, if we call this y, we know that y is equal to, well, doing it the same way, sine 5 sine of 15 degrees. Right? I skipped a step, right? Because we could say that sine of 15 degrees is equal to the opposite, y, over the hypotenuse, over 5. And then that step takes us here. We just multiply both sides by 5, and you get y is equal to 5 sine of 15 degrees. So that's pretty cool. We know this y, we know this x. Can we figure out what this length is? Let me draw it in yet another color. Can we figure out what the length of this side is? Well, we know from the problem that this whole length is 10, right? We know this whole length is 10. And we know that this little part of it is x, which is, we figured out, is 5 cosine of 15 degrees. So let's call this z. We know that z is equal to 10 minus x, right? Because this whole thing is 10. This thing is x, so z is equal to 10 minus x. And we already figured out what x is equal to. Z is equal to 10 minus this. That's what x is. We didn't even have to use the variable x. We could have just written it like that. So 10 minus 5 cosine of 15 degrees. Right? That's this side. Z is equal to 10 minus 5 cosine of 15 degrees. So we know z, we know y. This is a right triangle, and we're looking for this yellow side, whatever we want to call it. That's the answer to the problem. Well, this is starting to look easy. This is just the Pythagorean theorem. So let's just, y squared plus z squared is going to be equal to our, let's just call this, I don't know, let's call this m, picking an arbitrary letter. Let's call that m. So y squared plus z squared is going to be equal to m squared. So we could just say, let's just write that down. I don't know why I picked m, really just to confuse you, I think. So m squared is equal to, well, what's y squared? Y squared is 5 sine of 15 degrees. So it equals, let me do it in that color, 5 sine of 15 degrees squared plus, what's a z squared? Z is this, right? Z squared plus, I'm running out of space, 10 minus 5 cosine of 15 degrees squared. And now I just have to simplify this. And if you have a calculator, I mean, you could do this without any simplification, but I want to get it as simple as I can. So let me just, so what's this squared? Well, this is equal to, let me draw a line here because I don't want to get too messy, but I need all of this space. So this is equal to, what color am I using now? This is equal to, and remember, this is m squared. We're going to have to take the square root of all of this at the end to solve for m. So this is equal to 25 sine squared of 15 degrees, or the sine of 15 degrees squared. That's just how you write it. And then we do a little bit of FOIL here to expand this. So plus, let's see, 100 minus, this is just expanding this expression, minus 100 cosine of 15 degrees plus 25 cosine squared of 15 degrees. All I did is I expanded. I said, well, this whole expression squared is equal to this squared minus 2 times the two things multiplied out, so that's 100 cosine of 15 degrees. And then I just squared this last term, which is plus 25 cosine of 15 degrees. If that confused you, you might want to review the multiplying expressions. So let's see if we can simplify this further. So if we take this term and this term, we could simplify that to 25 times sine squared of 15 degrees plus cosine squared of 15. And you could kind of skip all this and just use a calculator and figure out this exact value. But I'm just going to keep working on it just because I like to get it as simple as possible before I use the calculator. So that term and that term are that. And then it's plus this stuff. Plus 100 minus 100 cosine of 15 degrees. Right? And then what is the sine squared of 15 plus the cosine squared of 15? That's one of our most basic identities, right? That's the Pythagorean identity. And sine squared of x plus cosine squared of x, or of theta, is just 1, right? So this term becomes 1. And I'm running out of time, so I'll continue in the next video.